Alright, so in this section we have a bunch of different derivative rules that we're finally able to learn. The first one is the derivative of a constant. If you have y equals a number, you would expect it to have a slope of 0 because it's a horizontal line which has slope 0, so its derivative should equal 0. Then they talk about the power rule. The power rule says if you got some number or some variable raised to a power, you just bring the power out front, multiply it out, bring it out front of the term, and then subtract 1 from the exponent, and that's called the power rule. So x to the 6th becomes 6x to the 5th, x to the 1000 becomes 1000, x to the 999, t to the 4th becomes 4t to the 3rd, r to the 3rd becomes 3t to the 2nd. And if you've got something written in fraction form, you might want to write it in this form so it's easier to see what the first derivative is. You bring the negative 2 out front, and then subtract 1 to give you a negative 3. And then you want to rewrite it using that, bringing that negative across the fraction bar to make it a positive exponent. Remember fractional exponents, the root is your denominator, the numerator is your power. So 2/3 means squared and cube rooted. So x to the 2/3 derivative is 2/3 x to the 2/3 minus 1, or minus 1/3. And you could simplify that and bring that into your denominator and write it as x to the positive 1/3 if you wanted. You don't have to. This one, x times square root of x is x times x to the 1/2, or 1, x to the 1, x to the 1/2, or x to the 3/2. Now when you take the derivative, it's 3/2 x to the 1/2. You subtract 1 from the 3/2. And 1/2 power is just square root. They actually ask you to find the slope of the tangent line. Now that you've got your first derivative, just plug in the x value to get your slope, which you find is 3/2. Use 1, 1, and you can find your slope. To find the normal line, you use the negative reciprocal of the tangent line's slope. So if this slope is for your tangent line, negative 2/3 is your slope of your normal line. When you multiply a constant times a function, the derivative is just the constant times the derivative of the function. So the 3 doesn't change when you take the derivative. You still have to bring the 4 out front and subtract 1, and 4 times 3 will give you 12, and you subtract 1 to give you 3 in your exponent. Negative x is really negative 1 times x, and the derivative of x is just 1, and so 1 times negative 1 is negative 1. When you're taking things that are being added, the derivative is just the derivative of each term. Same thing with subtraction. So if you got a whole bunch of things that are added or subtracted, just take the derivative of each one. Just bring the number out front, subtract 1, number out front, subtract 1, number out front, subtract 1, all the way down. Alright, this one here, same thing. Bring the 4 out front and subtract 1, bring the 2 out front and subtract 1, and a constant will just give you a 0. This one, the first derivative is your velocity if the original function is your position, which it is. So you bring the 3 out front and subtract 1, you bring the 2 out front and subtract 1, you just write 3 instead of 3t. That's your first derivative. Now take the derivative of that to find the acceleration. So you bring the 2 out front and you get 12t. Derivative of 10t is just 10. This part gives you nothing, gives you 0. An interesting one is e to the x. The derivative of e to the x is e to the x. So when they ask you to take the derivative of e to the x minus 1, this first part, when you take its derivative, it doesn't change. But we know the derivative of x is just 1, so you just get e to the x minus 1. Now if you were to take another derivative, again, e to the x's derivative is e to the x. Derivative of 1 is 0, so you just get e to the x here. So now they're asking you to find the derivative of these guys. So derivative of t cubed is 3t squared, and e to the 3rd, that's just a number, so its derivative is 0. E to the 6th is the number, so its derivative is 0. 4x's derivative is just 4, derivative of 7 is 0. This one you bring the 3 out front, negative 3 out front, and subtract 1. Here, you're going to want to multiply this out and get x to the 4th plus 3x to the 3rd, and then take the derivative. Here you're going to want to expand this and then take the derivative of each individual term. And this one you can do the derivative, it's not too tricky there. This one you're going to want to do a rewrite. You're going to want to write that as t to the negative 1 and t to the negative 2 and then take the derivative of each one. And then you can rewrite it with t squared in the bottom and t cubed in the bottom there. This one you want to expand it out and take the derivative of each term. Okay, and this one you expand this out and combine like terms, so combine your x to the 1/2 with your x to give you 3/2, and this one gives you 1/2 for your exponents. And then you're able to take the derivative and you get 1/2, which is square root of x, and here you get negative 1/2, which is square root of x in the denominator. This one you want to write 2w to the second over w to the 1/2, and when you get a 2 over 1/2 you get a 3 over 2. And this is w to the 1 divided by w to the 1/2, which gives you w to the positive 1/2. And then 4 over w to the 1/2 is 4 times w to the negative 1/2. When you write each one of these with this denominator, you can combine your w's and rewrite things. Then it makes it easier to take the first derivatives. Okay, and then this one you want to multiply everything out and then take your derivative. Here, this is the cube root of, or square root of 3 times u to the first power. But this is the square root of 5u. The u is underneath the square root. So this is really the square root of 5 times u to the 1/2, or the square root of u. Okay, so this guy is just the constant that's in front. This guy you got square root of 5 times 1/2 u to the minus 1/2, and you can simplify that. This one, fifth root means 1/5 power. Second root, fifth power means 5/2 is your fractional exponent, and you bring each one of those exponents out front and subtract 1 from your exponent. This one, you might want to write this as x to the 1/2, and this right is x to the negative 1/3, and then multiply it times itself, and you get a bunch of terms here. And once you finally simplify it as much as you can, now you take the first derivative. Here, e to the x plus 1, that's e to the 1 times e to the x, right? And e to the 1 is just a constant. And so a constant times e to the x is just e times e to the x. Derivative of 1 is 0 since it's a constant, and so e to the 1 times e to the x is e to the x plus 1. Okay, now this one, first derivative is 6x to the first minus 3x to the second. You plug in 1 for x to get your slope, and you use that point to find your tangent line. Here you take the derivative and you get 4x to the third plus 2x plus 2e to the x, and now you plug in the x value of 0 to get your slope, and you can figure out your tangent line at that point. They ask you to find the normal line as well, so this slope is positive 2, the slope is negative 1/2. Again, reciprocals and negative of each other. First derivative, you take the derivative of that one, that's not too bad. This one, you bring the 5 out front and subtract 1. Bring the 3 out front and subtract 1. And you can do the derivative as well. You bring the 4 out front and subtract 1. Bring the 2 out front and subtract 1. This one asks you to find the first and second derivative. So the first derivative is just 3t squared minus 3. The second derivative, this part goes away to 0, but this gives you 6t. So your position is this one, your velocity is this one, your acceleration is that one. Okay, so find the points where the tangent is horizontal. So you find the first derivative and set it equal to 0. So you take the first derivative, set it equal to 0, and these are the places where the tangent line is horizontal, but they want to find points where it's horizontal, so you got to find the y-coordinate given certain x-coordinates that you found. Alright, in this one, you want to find the first derivative, so you bring the 4 out front, subtract 1, the 1 goes away, it's just derivative of that, it's just 0. And they wanted it to equal the same slope as this line. This line's slope is 32, so this one equals 32. You solve for it and you get x equals 2. Now when x equals 2, y equals 17. So at the point 217 with slope 32, you have an equation of a tangent line that's parallel to the line they give you here.